This is number 29 from the 2013 mock contest, sprint round number 2. And it says, how many three-digit numbers of the form ABA exist such that A and B are distinct digits and ABA is divisible by 3? And so when doing this, you have to kind of think through how you're gonna count these problems. We're obviously going to use our divisibility rule for 3, which is you sum up the digits to get to 3. And so I'm just going to start by counting by doing A. So if A is 1, well, then B can be, well, it could be 1 plus 1 and 1. However, if you add a 1 in there, the problem with that is you violate the distinct digits. And so we can't have 1 plus 1 plus 1 to get to 3. So instead, we've got to do 1, 4, 1 to get to 3, and then 1, 7, 1. And so there are two ways of getting there with a 1. With the 2's, well, it's the same idea in that you can't get there using the 2's because you'll have 2, 2, 2 doesn't work, but 2, 5, 8 does work. With 3's, well, in this one, 3 plus 3 is 6, and so all you need to do is do multiples of 3, so your middle number could be a 0, or it could be a, well, not a 3, but a 6, and a 9. And then after this, you'll start to see that these are going to be similar to that the 1, the 4, and the 7 are going to go together. And so 4, 1, 4 is divisible by 3, and so is 4, 7, 4. But 4, 4, 4 is 2, but we can't count 4, 7, 4, and so we can do 1 and 7. And so you actually start to realize that the numbers are grouped together as we've seen. And so 5 is going to have 2 possibilities. 6, just like 3, is going to have 3 possibilities. 7 is going to have 2. 8 is going to have 2. And finally 9 is going to have 3. So the total number of possibilities is just adding these up, plus 2, 3, 2, 3. And when you add all those up, you end up with well, this was 2 here, my bad. You end up with 21. And so there are 21 numbers that when you divide, that can be written as ABA, where A and B are not the same number, and you divide it by 3 evenly.